Hello my dear students, I warmly welcome you to Sia's digital classes. In this lecture, we are going to discuss about one of the important definitions from the second unit. So let's see what is the definition first of all and how it will be the question in the examination format. Okay. So first of all, see the question. Define stabilizer of a point. Define stabilizer of a point and give examples for the stabilizer. And define orbit of a point and give examples for the orbits. For the examination purpose, these two definitions are very important. Okay, in the examination, if you define any definition, okay, so definitely you have to give the at least one example. Okay, then only you will get the full questions, full marks. So therefore, here we are entering into the solution. First of all, see the definition of the stabilizer of a point. Okay, stabilizer of a point, in the name only clearly we have stabilize. Stabilize means steady, constantly. Okay, there is no change in the place of the value. Okay, so that means steady, constantly, there is no change in the place of a constant. So therefore you can see the definition. Let capital G be a group of permutations. Let capital G be a group of permutations of a set capital S. Here capital S is a finite set. Okay, you can take that capital S is equal to A, B, C, D up to so on small I up to so on small n. Small n is the last element. Okay, capital S is a set. In that set we have finite number of elements. Okay, for in general I am taking in place of 1, 2, 3. So I am taking A, B, C, D up to so on small I up to so on small n. N is the last element and I is the one of the element of S. Then for each small I in capital S, if you take any element, okay, in place of I, if you take A, B, C, D up to so small n. So now in the elements of capital S, I am representing with small I. In place of I, you can take anyone, A, B, C, D. Okay, so therefore for each element small I in capital S, the stabilizer of a point small I is denoted by stabilizer of small I in capital G. Okay, stab of I under capital G. Okay, so this is the mathematical notation for the stabilizer of a point. Okay, this is the mathematical notation denoted in this format, and the set defined as stabilizer of small I in group G is equal to pi of I is equal to I, where phi is the mapping. Okay, and pi of I is equal to I means, so here I is the pre-image, small I is the pre-image, that means codomain value. Okay, and pi of I is the image value, so that is the domain value. So therefore stabilizer of I is equal to pi belongs to capital G, pi is a mapping, pi belongs to capital G, it is a function, and image of I, okay, pi of I is equal to I. So this is the definition. That means if you take any element, that image also should be equal to the same element only. For example, if you take 1, again the image of 1 also again you will get 1 only. Okay, so in the domain if you write in this format, if you take 1 here, in the codomain also you can write the image value for 1, pi of 1 only. Okay, pi of 1 also again the same element only. If you take 2 here, pi of 2 also 2 only, then that is called a stabilizer. Stabilizer is nothing but there is no change. Okay, constant in the domain and codomain, there is no change in the value of the given element. Okay, that is called a stabilizer. Stabilizer of a point. That is the mathematical notation. Pi of I is equal to I. In if domain in the domain if you take small I, in the codomain also image value also pi of I, the value does not change. That called stabilizer of a point. Okay, in the examples we can learn about clearly. Stabilizer of I, we read it as the stabilizer of I in capital G. This mathematical notation we have to read in the format of the stabilizer of I in capital G. Okay, where capital G is a group. Okay, so it is a permutation group of the capital S, where capital S is a finite set. Next, second definition, orbit of a point. In the name only clearly we have orbit. Orbit is, it is nothing but in Telugu orbit means kaksha. So it is in the format of elliptic. So therefore you can write orbit of a point. Orbit of a point means, for example, if you start one point from here, okay, it goes to anywhere, okay, but again it has to come to the same point. Okay, that is called orbit. Okay, irrespective of its length, you can there is no interruption between the starting point to ending point. So now you can see the definition. Let capital G be a group of permutations of a set capital S. Okay, same here also set to you can write in this format only. And for each small I in capital S, the orbit of a point small I in capital S is denoted by orbit of small I under G, and the same set defined as orbit of I under G is equal to simply pi of I. Okay, pi of I, such that where pi belongs to capital G, it is a function, and I belongs to S, is a subset of S, is called orbit of I under capital G. Here orbit is nothing but, so whenever solving the permutations, okay, so while taking the values of the permutation, for example, if you start with 1 to 2, again then in the next permutation 2 to 4, in this format, that cycle wherever ends, the total ending cycle is called one orbit. Okay, so therefore you can see the mod of orbit of I under G denotes the number of elements in orbit of I in G. So therefore orbit of a point is a subset for the set capital S. Just remember that point only, it is a subset, and that is the only same value. Pi of I is equal to I is the stabilizer, and only pi of I is the orbit. So these are the two definitions. Now we are discussing two examples for this stabilizer and orbit. Okay, first example 1. Let capital G be a subgroup of S suffix 8. What is the S suffix 8? S suffix 8 is the symmetry group. Okay, symmetry group of permutations of degree 8. Symmetry group of permutation with degree 8. Okay, so therefore that is the total number of the elements is equal to 8, and the highest number is 8. That is called degree of 8. And here capital G is less than or equal to S suffix 8. I am taking that capital G is equal to cycle 1. Okay, cycle 132, cycle 465, 78, 132, 465, 132, 456, 132, 123, 456, 78, and 78. These are the disjoint cycles of S suffix 8. If you consider first cycle 1, okay, from that group I am writing this total capital G is the representation of the permutation in terms of disjoint cycles. Okay, now I am splitting them into permutations. Those disjoint cycles now I am writing into permutations. Okay, you can see clearly. So if you write 1 in S suffix 8, so that means that identity permutation 1, 2, 3, 4, 5, 6, 7. Okay, starting with 1, ending with 8. And again for 1 you have 1 only. For 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. Okay, so this type of identity permutation we can denote with epsilon or small e or alpha power 0, whatever it may be. Okay, whenever you write only one cycle, okay, depending upon the symmetry group, if you write 1 in S2, what is the meaning? If you write cycle 1 in S2, that gives the meaning of 1 to 1 2. S2 means the symmetry group of degree 2. If you write 1 in S3, okay, 1 in S3, what is the meaning? 1 2 3, 1 2 3. In this format, same 1, okay, cycle 1, okay, length of the cycle is 1. Okay, so if you write in S suffix 8, you have to expand the total permutation up to degree 8. Okay, so that is the meaning. Or else if you write 2, okay, in place of 1, if you have 2, again also you will get the same identity set only, identity permutation only. For 1 1, for 2 2, for 3 3, up to so on. That is the representation. Okay, if you write only 3, that is also gives the same permutation. Okay, so those are the representations of the identity permutations. Next, the second disjoint cycle is nothing but here 1 3 2, 4 6 5 7 8. That is the second disjoint cycle. 1 3 2, 4 6 5 7 8. Now this disjoint cycle I am writing into the permutations. Okay, in the examination for the short answer paper from unit 2, you will get in this format. They will give the permutation. That permutation you have to convert into the disjoint cycles. Okay, they will give 2 permutations or 3 permutations. Express them in terms of disjoint cycles. Then you have to write in this format. Now in this problem we are doing reverse, okay, further to get the arbiter and stabilizer. So disjoint cycles we are converting into permutation. So therefore first of all, in this permutation the first row, okay, this is called array. First array is as it is trivial 1 2 3 4 5 6 7 8. After that 1 goes to 3, okay, 1 goes to 3. Next 3 goes to 2, this 3 goes to 2. Next 2 goes to 1, 2 goes to 1. In this format you have to fill up the second array. Next 4 goes to 6, 4 goes to 6, and 6 goes to 5, 6 goes to 5, and this 5 goes to 4, 5 goes to 4. And in that cycle only you have to take the orbits, okay. So next 7 8 is there, okay, 7 goes to 8, and again 8 goes to 7, 8 goes to 7. In this format you have to write a permutation, okay. In this format for each and every disjoint cycle you have to convert into permutations, okay. Here we have 1 2 3 4 5 6 disjoint permutations we have, okay. All 6 disjoint permutations we converted into permutations, okay. All disjoint cycles we converted into permutation. And the last one you have 7 8, okay. It is a 2 cycle, length of the cycle is 2, and it is a disjoint cycle. There is no 1 2 3, only 7 8 is that 7 to 8 and 8 to 7. What about the remaining values? 6 to 6 only, 5 to 5 only, 4 to 4 only, 3 to 3 only, 2 to 2 only, 1 to 1 only. No need to represent them, okay. Whenever you have 7 8, you have to write in place of image value. This 7 is nothing but pi of 7, okay. That pi of 7 is equal to 8. Here this 7 you can write 8 is equal to pi of 8 is equal to 7. In this format you can write, okay. So after taking the disjoint cycles, those disjoint cycles we have to split into permutations, okay, in this format. Now our work start. So now we have to find out the orbit of a point, stabilizer of a point. First of all I am finding the orbit, okay. So orbit of 1, okay, orbit of 1 you can take from these disjoint cycles, okay. So from this disjoint cycle you can find the orbit of 1. Orbit of 1 I am writing here. Here first of all I am taking the cycle 1 3 2. Cycle 1 3 2 is there. This cycle you can write 1 2 3, and 1 goes to 3, and 3 goes to 2, and this 2 goes to 1, okay. From 1 goes to 3, 3 goes to 3, 3 goes to 2, and 2 goes to 1, and this 1 goes to, in this format. There is no interruption between the cycle, okay. This total gives one orbit. The total cycle gives one orbit. So therefore one orbit of 1 started with element 1 is equal to 1 3 2. You can write in this format, okay. So if they ask orbit of 5, you can write this value 4 5 6, 5 4 6, whatever it may be, okay. So therefore in this format orbit of 1 you can write in this format. Orbit of 1 is equal to 1 goes to 3, and 3 goes to 2, and 2 goes to 1. The total complete cycle started with 1 and goes to 3, and started with 3 goes to 2, and started with 2 end with 1. This complete cycle give one orbit, okay. This is called orbit of element 1 started with 1. Next orbit of 2. If you start with 2, that cycle also you have to start with 2 only. 2 to 1, 1 to 3, and 3 to 2, in that format. From the disjoint cycle only you have to select that orbit, okay. So next orbit of 4, okay. You can see here orbit of 4 you can start with any permutation. 4 to 5, 5 to 6, 6 to 4. So that is only they are writing 4 to 6, 6 to 5, and 5 to 4. Here also you can write 4 to 5, 5 to 6, and 6 to 4 in this format. That is gives one perfect orbit. Next orbit of 7. Orbit of 7 means then you have to select this cycle, okay. Orbit of 7 means 7 to 8, 8 to 7, 7 to 8, 8 to 7. That is the only one orbit, okay. So in this format you have to find out the orbits, okay. From the disjoint cycles, after taking the disjoint cycles, we have to split them into permutation. By observing the given permutation, you will know that the orbit of any value you can find. Orbit of any value you can find, okay. Those only set of the elements only. Here 1, 2, 4, 7. These are the small I is equal to 1, small I is equal to 2, small I is equal to 4 and 7. These all are the elements of capital S only. In elements of capital S, 1 to 8 is there. So therefore those are the only elements. For them only we are going to find out the orbit. And now stabilizer. You can see the stabilizer. According to the definition of the stabilizer, what is the definition? Pi of I is equal to I. Pi of I is equal to I. So first of all, I am finding that stabilizer of 1. 1 is the element from S. For that one, I am going to find out the stabilizer. Okay. So stabilizer of 1 we can find. First of all, if you take 1, the image value of 1 also will be the same number. ఇక్కడ మనం 1 తీసుకుంటే ఆ 1 కింద ఉన్న వాల్యూ కూడా మనకు 1 అవ్వాలి. 2 తీసుకుంటే 2 కింద వాల్యూ కూడా మనకు 2. ఆ కింద వాల్యూ ఏంటంటే ఇమేజ్ వాల్యూ ఇక్కడ. Okay, so in that format we are writing the stabilizers. Okay, here you can see that stabilizer of 1 అనేది ఈ ఫస్ట్ డిజాయింట్ సైకిల్ లో ఎగ్జిస్ట్ అవుతుంది. ఎందుకంటే ఫస్ట్ డిజాయింట్ సైకిల్ లో 1 కి ఇమేజ్ 1 ఉంది. నెక్స్ట్ 7,8 అనే లాస్ట్ డిజాయింట్ సైకిల్, ఇక్కడ 7, 8 అని ఉంది కదా, ఈ లాస్ట్ డిజాయింట్ సైకిల్ లో కూడా 1 అనే ఎలిమెంట్ కి ఇమేజ్ 1 ఉంది. మిగతా మీరు ఏ సైకిల్ తీసుకున్నా ఇక్కడ 1 కి 2 ఉంది, ఇక్కడ 1 కి 2 ఉంది. ఆ రెండు డిఫరెంట్ ఇమేజెస్. 1 is the pre image, 2 is the another image. But only first 1 అనే సైకిల్ కి, లాస్ట్ సైకిల్ 7, 8 అనే సైకిల్ కి ఓన్లీ 1 కి మీకు 1 ఇమేజ్ ఉంటది. ఓకే, సో దీస్ ఆర్ ద స్టెబిలైజర్స్ ఆఫ్ ఓన్లీ 1. ఇంకా వేరే ఎలిమెంట్స్ కి ఏమున్నా మనకు అనవసరం. ఓకే, ఫర్ ఓన్లీ 1 we have first cycle and last cycle is the stabilizer. ఓకే, నెక్స్ట్ స్టెబిలైజర్ ఆఫ్ 2 అనే ఎలిమెంట్ కి స్టెబిలైజర్ ఏమేమి వస్తాయంటే సేమ్ దానికి కూడా 1 అనే ఫస్ట్ డిజాయింట్ సైకిల్, 7, 8 అనే లాస్ట్ డిజాయింట్ సైకిల్. యూ కెన్ ఆల్సో షో హియర్ 2, 2 కి 2 నే ఉంది. నెక్స్ట్ లేదంటే మీరు ఇది తీసుకున్నారు అనుకోండి, ఈ సైకిల్ వస్తుంది అనుకోండి, ఇక్కడ 2 కి 3 ఉంది, ఇక్కడ మీకు 2 కి 3 ఉంది. కాబట్టి డిఫరెంట్ ఇమేజెస్ కదా. మనకి ఏం ఫార్ములా కావాలి? పై ఆఫ్ ఐ ఈజ్ ఈక్వల్ టు ఐఏ కావాలి, పై ఆఫ్ 2 ఈజ్ ఈక్వల్ టు 2 నే కావాలి మనకు. ఓకే, పై ఆఫ్ 2 ఈజ్ ఈక్వల్ టు 2 నే కావాలి. కాబట్టి 2 కి 2 ఎక్కడ ఎగ్జిస్ట్ అవుతుంది అంటే ఓన్లీ ఫస్ట్ డిజాయింట్ సైకిల్ అండ్ లాస్ట్ డిజాయింట్ సైకిల్ లోనే ఎగ్జిస్ట్ అవుతుంది. నెక్స్ట్ స్టెబిలైజర్ ఆఫ్ 4 అనే ఎలిమెంట్ కి తీసుకుంటున్నా. సేమ్ ఇక్కడ కూడా ఫస్ట్ డిజాయింట్ సైకిల్, ఇక్కడ కూడా 4 కి 4 ఉంది ఇమేజ్. ఇంకా మీరు ఇక్కడ ఒకవేళ ఇక్కడ తీసుకున్నారు అనుకోండి, 4 కి 5 ఉంది ఇమేజ్, అది స్టెబిలైజర్ అవ్వదు. ఎక్కడైతే మీకు 4 కి 4 ఉంది అనుకోండి, దెన్ ఇట్ ఈస్ టేకెన్ యాజ్ స్టెబిలైజర్. నెక్స్ట్ లాస్ట్ చూడండి, స్టెబిలైజర్ ఆఫ్ 7. ఓకే, 7 అనే ఎలిమెంట్ కి ఫస్ట్ సైకిల్ లో ఎగ్జిస్ట్ అవుతుంది. 1, 3 to 4, 5, 6 ప్రీవియస్ వన్ 1, 3 to 4, 5, 6, 1, 3 to 4, 6, 5. ఇక్కడ కూడా మీకు 7 కి 7 ఉంది, ఫస్ట్ సైకిల్ లో 7 కి 7 ఉంది. ఓకే, నెక్స్ట్ ఏమన్నాడు ఇక్కడ 1, 2, 3, 4, 5, 6, దట్ దిస్ వన్ 1, 2, 3, 4, 5, 6 ఈ సైకిల్ లో కూడా మీకు 7 కి 7 ఉంది. ఓకే, సో ఇన్ దిస్ ఫార్మాట్ ఆఫ్టర్ రైటింగ్ ఇన్ టర్మ్స్ ఆఫ్ కాంపిటీషన్ యూ హ్యావ్ టు అబ్జర్వ్ దెమ్. ఏ నెంబర్ కి పైన రోలో ఉన్న ప్రతి నెంబర్ కింద రోలో కూడా సేమ్ ఉంటే ఆ ఎలిమెంట్లను ఏమంటామంటే మనం స్టెబిలైజర్. ఓకే, ఆ మొత్తం పర్ముటేషన్ ఏం తీసుకుంటామంటే స్టెబిలైజర్ కింద కన్సిడర్ చేస్తాం. సో ఫర్ 7 కి ఫస్ట్ డిజాయింట్ సైకిల్ లో 7 కి 7 ఉంది, సెకండ్ డిజాయింట్ సైకిల్ లో 7 కి 7 ఉంది, అండ్ దిస్ వన్ ఫోర్త్ వన్ లో కూడా మనకు 7 కి 7 ఉంది. అండ్ ఇక్కడ తీసుకున్నారు అనుకోండి 7, 8 లో 7 కి 8 ఉంది, ఇక్కడ 7 కి 8 ఉంది, అండ్ 8 కి 7 ఉంది. ఇక్కడ మనకు అది స్టెబిలైజర్ అవ్వదు. ఇన్ దిస్ ఫార్మాట్ you have to find out the stabilizers of any element in the set capital S, orbit of any element in capital S. Here you have second examples also, you can go through that example. Okay, so this is the example number 2. So we have in the disjoint cycle forms, from them you can directly know that. Okay, so in the examination if you get this question, first of all these disjoint cycles you have to write in the form of permutation. I clearly explain you. Okay, so 1 it is also in the last term is 6 is there, it is in the S suffix 6. Okay, S suffix 6 is the permutation group. So here if you write means 1 means what is the meaning of 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. This is the meaning because S suffix 6 degree is the 6, up to 6 you have to expand that permutation. Okay, so now stabilizer of 1 first disjoint cycle. Okay, 1 ki 1 ne undi, 2, 4, 5, 6. Where is the 2, 4, 5, 6? Last one lo kuda 2, 4, 5, 6 is there, 2, 4, 5, 6. If you expand this cycle there is no 1, That means 1 to 1 only image. 2 is there. 2 to 4. Next to 3 is not there. 3 to 3. Next to 4 is there for 4 to 2. Next to 5 is there 5 to 6. And the next to 6 is there 6 to 5. In this format you have to write down the permutation. Okay. So in this format you have to find out the stabilizer of any element in the given set capital S and orbit also 1, 2, 3, 4. In this format you can find out the orbital and stabilizer of any point. Okay. So these are the best examples to understand the concept of stabilizer of a point and orbit of a point. I hope you understood this problem very well. In the next lecture we are coming with interesting theorem. Okay. So make a perfect practice, prepare well. So bye.